Hi, welcome to another awe-inspiring lesson using the TI Nspire with calculus. Today we're going to take a look at how we can find to solve a definite integral using the TI Nspire. Now remember, a definite integral, this finds the area underneath the curve. So in order to do this, we have two options. Option one, we could sketch the graph. We can graph it. Okay, from the graph, so if I graph this function, let's do this. This is x plus 3 quantity squared. And if I graph it, here we have, you can kind of see the graph right there. Now, I don't like to label things. I like to get rid of these. So I just highlight it, press down, and delete. And we're asked to find the area between -3 and 0. So kind of like this little curvy part here. Not a triangle, but a little curvy. So to get the area, what you're going to do is you can go to Menu. Just press Menu. Go all the way down to number 6 where it says Analyze Graph. Press Enter. And we're looking at the integral here, number 6. So already highlighted. I press 6. And then I just hit my domain. Well, my domain goes from -3 to 0. It says upper bound, and I just type in the number 0 right now. 0. I press enter. And the really kind of cool thing is, if you notice, it gives you the area right there. It gives you the area. And it's even Slim Shadys for you. And it gives you the answer, which of course is 9. Now the graph is very nice, but sometimes the graph doesn't do a very good job. Either the graph is too big or it's too complex. For example, if we take a look here, let's take a look at the next one, number 2 here. Let me clear this out, doc B. If I were to graph this one, cosine of x cubed, this takes a while. If you notice, it's very complex. Looking at the area is very hard for this one. So there's another way that I prefer to solve definite integrals, and that's at your home screen. So go back to the home screen right here, and you can type this in directly into your home screen. It's really kind of cool. So on your home screen, what you're going to do is you're going to go to Menu. Menu. And you go to Calculus. Oh, look, that might help us with calculus. So go to Calculus, press Enter, and we're looking at a numerical integral. This is a numerical integral. Numerical integral. So I'm going to go down to number 2, and I just press Enter. And if you notice, oh look, it looks just like the problem. And I can just type in exactly as it looks. -3. Go up here, go to 0, type in 0, type in the equation, open parenthesis, x plus 3 squared, and over here, don't forget your differential, type in x, and I press enter, and it gives me 9 as well. I like this method a little better, but to show you something else for it, since we already have this into our, so just a little easier to do. Now, so let's take a look at this one as well. So if I try solving this one using the calculator, now you cannot solve this by hand. Can't be integrated by hand. It's impossible. You can try u substitution. You would get u equals x cubed, du equals 3x squared dx. See, the x isn't going to cancel anything, and you're going to wind up with u and an x squared in the problem, and we can't have that. So we cannot solve this by hand. We can use what's called a Taylor series to solve this. We're going to talk about those later on, or I have another video as well. But what we can do here, though, use the calculator. Menu, 4, 2, your best friend, menu 4, 2, 0, go up to pi over 4, pi divided by 4, and I type in the equation. Cosine x to the 3rd dx. And I just press enter. And I get this 0.7724 for the area. Now, there's another way I could do it this one. You might recall I already have it graphed in under F1. So another way you could do this is you can go Menu, 4, 2, type in the same one, 0 to pi over 4. But this time I'm going to type in f of 1. I just type in the letter f, 1 of x, like so. I can do this because it's already graphed. If I don't have a graph, I just type it straight in like that. Either way is fine. But if you have a graph already, you can just use here, dx, and you get the same answer. Alright, hope this video was a little helpful for you guys, and heck, like me. Bye.